In this video, I will do a high-level overview of available ServiceNow reporting tools that can be used for analyzing datasets to identify virtual agent automation opportunities. For this video, I will be using the incident table as an example dataset. Currently, there are 5 tools that can be used to perform this analysis: incident discovery and topic recommendation, automation discovery, predictive intelligence clustering, and ServiceNow reporting. Each of these tools provide insight on patterns found in the analyzed records that are either associated with pre-built intents and/or related topics, or the analysis uncovers patterns in which automation can provide some sort of benefit. The first tool is intent discovery. I've grouped the intent discovery with topic recommendations since topic recommendations uses the results from intent discovery. Intent discovery analyzes the records in the specified dataset. In this case, we're using the incident table to get recommendations on available pre-built intents that can cover queries from users found from incident table records. These identified intents represent opportunities for incident deflection. For each matching intent, you have the option of adding it to a new or existing NLU models. Let's take a closer look at the intent discovery tool. To create an intent discovery report, navigate to NLU Workbench Intent Discovery. There are currently 3 completed analyses in my system. To create a new analysis, click on Run Analysis. You then need to complete the following fields to run the analysis. Select Data Source, which is a table that contains the data to be analyzed. In our case, we will stay with the incident table. Add data source conditions. Add any necessary conditions to exclude any records that are not relevant to the analysis. In our case, since our demo database contains limited data, we won't add any conditions. Select the field to analyze. The short description field is selected by default and typically provides you with the best information for determining the user's intent. Select the taxonomy. Taxonomy is a comprehensive list of pre-built intents for a specific business application. In this case, since we are running the analysis against the incident table, we will stay with the ITSM taxonomy. When we run the analysis, the incident records will be matched against intents found in the taxonomy. Add a report name. Running the analysis requires a minimum of 10,000 records, and you should not exceed 300,000 records. We're at about 13,000 records, so we are in the correct range, so we can proceed with running the analysis. Once the intent discovery analysis is completed, you can click on the report to view the results. A summary of the report parameters are displayed at the top: the data source, filter, field used for the analysis, taxonomy, total records analyzed, and the run date. The results are broken down into 2 tabs. The first tab shows that 25% of records are covered by recommended intents found in the ITSM taxonomy. And the second tab shows that the remaining 75% of the records do not have matching intents. The records covered by recommended intents tab lists, in descending order, the intents with the most matching records. Each row shows the number of records matched, the name of the intent, what's needed to add to the virtual agent, and the number of sample utterances. The rows can be expanded to show more details that includes the average time to resolve, language, assignment group, and the top short description value. You have the option to add the intent to a current model, a new model, or ignore. The 75% remaining records tab lists incidents clustered by similar short descriptions in descending order by number of records. Each row shows the percentage of records clustered, the number of records, and an example short description. Expanding each row displays the similar details as the first tab: the average time to resolve, language, assignment group, and top short descriptions. Since an intent was not matched with each cluster listed, you only have the option to add utterances to an existing intent or add a new intent. In the end, the intent analysis tool utilizes machine learning to provide an analysis to identify the top number of queries, and of those queries which are covered by predefined intents and which are not but should be. This helps assure that the topics created for the virtual agent provide coverage for the most common queries.